Hi, everybody. First of all, thank you so much for coming. I will say that if you come sit in the front, I will give you stickers. That is a thing that you can get. And they're great stickers. They're AWS Lambda stickers. This talk has relatively little to do with AWS Lambda, but I just like Lambda a lot. So have any of you seen me speak before? Great. So I have no reputation to ruin today. We're not getting started yet. We're going to let people come in for a little bit longer. But I'm curious, how many people are already using X-Ray? OK. How many people are planning on using X-Ray after this talk, having not seen any of the slides yet? Wonderful. Perfect. 100% of the audience. So my name is Randall. I'm a software engineer at Amazon Web Services. As a millennial, I take a lot of selfies. And I'm curious, would you guys be interested in taking a selfie right now? There's a point to this. So there's a demo. This corresponds to the demo later. If you don't want to be in the selfie, I don't know. I don't know how laws in England work. In America, it's just like tough luck. But also, spelling here is very strange. Have you guys noticed that? Like so Ashley is from Britain, I guess. And I had to correct the spelling on all of his slides. It's like everything was spelled with S's and no Z's. And all right, are you guys ready for this? Do you want to? All right. OK. OK, thank you, guys. So this is part of the demo that we're going to show potentially later. And now we're going to get started. So first of all, I wanted to say thanks to everybody for coming to this session. I know you have a choice in sessions today, and we want to thank you for flying with me. Coming to this session, there's a lot of really great content here at these summits. We put these on for developers like you guys who need to learn about this stuff in order to be more effective. And my goal today is to get you as much information in the shortest amount of time that I can. That said, this is a deep dive session. So I will be very technical. I will not be going slowly. And if you are not interested in a deep dive session, now's the time to get out, because there are other sessions that are more introductory that I think may be helpful. But this is going to be deep dive. Everybody OK with that? Great. And I'm going to try my best to avoid as much of the kind of AWS spin as I can. I'm going to try and be as open and broad about it as I can. So let's get started. This is me. You should follow me on Twitter. This is the only real takeaway from this. This is my actual Amazon email address. There's no filters. There are Lambda functions that auto-respond. But I would really enjoy it if everybody here shot me an email and was just like, hey, I'm planning on building this. Do you have any advice? My day job is to actually answer questions from customers, from developers. And I spend a lot of time doing that, and I'm very interested in doing that. So please send me your use cases. If you want me to retweet you or blog about something, I'm happy to do that. And I also want to say thank you to all the other people at AWS who worked on these slides. I've been trying to click to the next slide for a little bit, and it's not working. There we go. I have to point in that general direction. So what we're going to do is we're going to, and I also want to apologize to the cameraman briefly, because I'm a very energetic speaker. I'm going to be moving around a lot. Sorry, and thank you. OK, so first we're going to cover what is X-Ray. We're going to go over some core concepts, some vocabulary that's necessary for X-Ray. We're going to go and do a really quick deep dive on the API for Amazon X-Ray. And then we're going to go over some use cases, and Ashley is going to talk about that. And I don't know what getting started is. We're not going to do that. We're going to do some Q&A, though. OK, so how many people already have a microservices-based application deployed in production? For the purposes of any video audience later on, that was 100% of the audience. So how many people find this more difficult to debug than your previous iteration, whether it was a monolithic application or OK, so again, 100% of the audience. So we have these issues, right, when we move to microservices of not being able to instrument them using the software that we're used to, not being able to build them with the same frameworks and stuff that we're used to building with. I can't SSH into a server and run LSOF when I've got 150 different servers. It's hard for me to figure out how and where things are failing, especially when you're at a production load. So those are some of the challenges that we face. And X-Ray solves some of these challenges X-Ray solves some of these challenges by helping you to identify both latency and performance bottlenecks, exceptions, taking production data that's going through your system and creating telemetry around it that you can query. And the query aspect is very important. So this is X-Ray. I'm missing a slide. I'm sorry. Oh, no. Oh, well. So right now we have SDKs available for Java, .NET, and Node.js. There are a couple of different community frameworks that support many other languages, whether that's Go, Ruby, Python. I'll recommend some of those frameworks later, but Rackspace came out with something called Fleece, which I think is the most excellent Python framework for X-Ray right now. The SDKs that we've released also have instrumentation very easily, especially in Java, for instrumenting HTTP requests through Tomcat or various databases, MySQL, Postgres, and DynamoDB, and then queues and all of these other things. And in addition to that, every call that you make out to the AWS SDK will be instrumented. So what is X-Ray made out of? X-Ray has two kind of concepts here. There's like a whole section of my presentation that's like missing. I'm really sorry, I have to fix this. Okay, we're just going to go through it anyway. Sorry about that. Okay, so there are two key components. There's the SDK, which you run in your code. It's a library that you include. And then there's the X-Ray daemon. And the X-Ray daemon runs on your instances, whether it's on premises or in AWS, or even if it's in a Lambda function. The X-Ray daemon runs and collects metrics that are produced by the SDKs. So here's some key vocabulary words to kind of keep us moving. There's a trace. So a trace provides an end-to-end data analysis kind of ID for all of the services. So I'll show you what a trace ID looks like in a little bit. There's segments, and segments are kind of the portions of a trace ID that you're interested in diving deep on. So you can add various subsegments and annotations and metadata to each of these segments, and you can, let's say you are pushing data into DynamoDB and it's not scaling quickly enough, so you get throttled, and you want to figure out which of your requests are being throttled. That's actually really easy to do. So you have a trace ID, or you have a whole series of trace IDs, and you can put in brackets throttled on the service DynamoDB, or the name of your table even, and it will find you all of the traces that were throttled. And you can associate various metadata with each of these traces. So you can say, hey, I want to include the item that I'm trying to insert as an annotation in X-Ray. Then, obviously, that's a lot of data, that's a lot of telemetry to be moving around. So what we do to kind of minimize the performance impact of doing all of this tracing and all of this extra network traffic is we have something called a sampling configuration. And this is just a JSON document that allows you to define what stuff should be sampled, what stuff should be traced, and what things should not. And my general piece of advice for this is you should trace every single error. So anything that results in a user getting a 500 or a 400, you should absolutely send that telemetry up. And everything else, you can probably rely on only 10 to 5% of those requests being traced. OK, so the API, X-Ray provides a set of APIs that allow you to do both batch requests and single requests. You can also send traces that are currently in progress. So you don't have to wait for a request to complete to send all of the data. You can send it partially and then send an addendum to that later on. And you can get all of that data through various queries. So the batch get APIs allow you to construct filters and queries on the traces that you're submitting to kind of dive deep on the data more than what the current console allows you to do. Now, I have not yet run into a situation, and I do run production applications with a lot of daily active users. There's one called GitShots. Has anybody heard of that? What it does is it takes a picture of your face every time you do a git commit, and then it uploads that and a bunch of personal data to the cloud. And you can add .avi onto the end of your URL. Check out gitshots.com. Just saying, it's pretty cool. So you have a bunch of daily active users, you're trying to instrument all of this, you're trying to understand it, and I have not yet reached the point where I wasn't able to construct a query in the console that solved what I was trying to do. Now, when you get into more advanced use cases, you may need to go outside of the console. There's also something in the console called the service map, which is very, very pretty. Did you guys go to the keynote this morning? So in the keynote, I think Werner talked about X-Ray, and I think he probably showed a picture of the service map. I don't ever really use the service map. It's very pretty, though. Most of the time, I'm kind of diving deep on individual traces to figure out where something went wrong. So here's the API. There are really only 4. There are more calls than this, but these are the 4 main actions. You can put trace segments, you can batch get traces, and you can get the service graph. The service graph is defined as a JSON doc. One of the things that I wanted to say about the service graph that is not immediately clear is it's only showing a sample. So it's not a, it's showing a representative sample of all of the data that X-Ray has collected, but it is not showing a perfect high fidelity picture. Just like Elasticsearch and Kibana, it's only taking data points and honing in the resolution over time. So that allows us to send the information out a lot faster and reduce the amount of network traffic. And then get trace summaries just receives all of the individual segments within a trace. So this is what a segment document looks like. Does this have a laser pointer? I'm going to poke somebody's eye out. So this is what a segment document looks like. And it's really straightforward. You have this kind of ID, and you have a trace ID. This trace ID, I'll explain more about it later, but this is a version number. This is a hexadecimal encoded Unix epoch time, and this is a 94, 96-bit ID, unique ID that should be globally unique. And then you can also kind of do in-progress stuff, which is what I was talking about earlier. Oh, yeah, here, great. So this is what a trace ID looks like, 96-bit globally unique ID, which translates to about 24 hex digits, and then you have this kind of sampled equals 1 on the end. And this header, anything that has this header, most of the X-Ray SDKs will take that and start adding additional segments into that trace ID. So let's say you have traffic coming in over ELB. ELB will generate this header for you. Let's say you have a customer who's trying to forge a header. Well, we have protections against that too, and that's explained in a pretty detailed way in our documentation, but if anybody's interested in that, I can talk more about it. And then we also have this kind of parent segment ID, which is where you can say this trace is a child of this other trace. And you can build kind of a directed acyclic graph from this series of traces. And that's what helps us get that service map that I'll show in a little while. OK, that is a very fast speed through of the AWS X-Ray service. I'm going to let Ashley, who is an AWS customer and a software engineer at Skyscanner, come and talk about how they use X-Ray to build more effective microservices. So, Ashley, you want to?
Cool. Thanks, Randall. Yeah, that's me. I'm Ashley. I've been at Skyscanner for probably a year and a half. We recently took on to look at X-Ray about 3 or 4 months ago to decide to sort of think about how it could improve our microservices across Skyscanner. So has anyone not heard of Skyscanner for a start? Brilliant. I think most people, well, one person. So we have a goal to be the most used, most trusted online travel brand in the world. Ambitious goal. So with that comes like a lot of complexity. We're approaching 100 million monthly unique visitors to the site. We're getting towards 1,000 microservices in AWS as well. We do thousands of deploys. In fact, we have a stretch goal of 10,000 deployments a day to AWS. That's kind of our goal. That we want to iterate changes, get very quick feedback cycles. So with this like massive complexity, it comes to a point where like no single person understands the whole system. The complexity is so vast that you need tools and things to help you to actually understand parts of the system. So we have goals of 100% availability. The site going down for maintenance is absolutely not acceptable nowadays. We need to be 24/7 availability as a global product across the whole site. So what does AWS X-Ray give us? So request tracing gives us the ability to track requests around this vast, complex system. From the very first user, like searching on our website to get some flight details, to then getting the flights in return, and everything in between, the thousands of microservices that request hits during. So what have we built? So we've added X-Ray to, we have projects to enable engineers to create Java services. We use Java Drop Wizard and Node React for creating services, and we've supplied wrappers for the Jersey client and Request and Request Bomb is native Node clients for doing HTTP calls between services. We promote functions for developers to wrap particular bits of code. So we're going to see some examples of this in a minute, but what we've got here is, I don't know how the laser works, but up there, there's basically you can wrap particular sections of code, maybe problem bits of code or particularly compute-intensive bits of code that you want to trace, you want to know more about. We've added the ability to wrap, for developers that easily wrap like bits of code around tracing and then be able to see the results of that. We've added simple annotations, the @trace subsegment to, this is for Java, so people can just add that annotation to a method, and then that will immediately be traced and then can be visualized in X-Ray that we're going to see in a minute. The next really cool thing that we've built is like X-Ray has deep linking, so you can create a URL that will link right into X-Ray. So we have, at the top here, we have a log message that's logging in Kibana, like some errors occurred, 500 or something. And then there's a field that's actually the link at the end, the hyperlink. It says the trace link there. A developer can click. They see the error, they might get an alert on the error, and they can click the link and be linked directly into X-Ray, and they can start digging deeper to see what the problem was and find out more about it. So, like, all these features sound great, but like, how does X-Ray actually help us? You know, it's just we want to do request tracing, but why? So we've got a couple of use cases I'm going to talk about. So the first use case is like understanding your dependencies. So when your system is like this, it was simple. Or when you're like, you have a monolithic application or whatever, it's just one service, and you can kind of understand, like, you get the repo, you see all the code, and you can maybe understand when you've got something like this as well, where you've got different services talking to each other. But when you have systems like this, and obviously it's much, much more vast than this, when you've got thousands of microservices, what do you do when, like, service way far away from yours goes down or starts submitted like a bug, or it's behaving badly for whatever reason, and you're dependent on it through like chains of different services? How do you even like find that out? I mean, like we've had an instance where, for example, we've got like a sandbox test environment, and production services might be referencing that sandbox environment, and we don't know that that's the case. That's a mistake. That shouldn't be happening, but we don't really know that until we shut down a sandbox service, and then it's like, something on production is broken. We didn't have the oversight of that. So X-Ray allows you to, this is the service map Randall was talking about very briefly. So this is just one example of like a client request coming in, and we see it's hitting a service, in this case, the very first like circle, and then it's fanning out to multiple different services. So you might think that your system looks something like this. Like, I've got a service and I depend on these bunch of different services. But what X-Ray gives you is like the real data, what actually is happening, who's actually calling what. So then actually you might end up something like this, like, oh, actually I'm calling services I didn't realize I was. Or like I'm calling these caches actually because I'm connected to this guy, and this guy's added a new dependency that I didn't know about and stuff. So you really start to get more oversight about your system and your dependencies. So this is the first use case. Like, X-Ray helps us to understand the complexity of our distributed systems, which in a way that like logs can't. The service map in particular allows us to visualize the system as a whole and dive in and out where we need. You can select on a service map, dive into a service, see dependencies like that. So the second use case is on troubleshooting. I've got slow performance here, but it's troubleshooting problems, basically. So imagine you get an alert, something's decreased in performance. You might get latency of an endpoint or whatever has gone to a point where it's not acceptable anymore. You get an alert on that. So how would you debug that? You might look at the code. You might look at the recent commits. You might start trawling through the logs. These are all like things that you do as an engineer, but let's try using X-Ray instead now, and see sort of how it could help. So what I'm about to show you is a genuine bug that was found using X-Ray like a month or 2 months ago. So they had a service that was performing a bit slower than expected. So we will look into the trace and see what's going on. So this is the trace view. I'm going to dive into a little bit of the sections here. So what we have here at the top is a service, OC Registry it's called, and there's a particular set of functions that are called, which at the top, essentially the main call took 43 milliseconds. And then there's this next line down. It says UMS generate URL. I appreciate it's probably too small to read, but it says it takes 41 milliseconds, and it did a couple of remote calls and such. So that's what the trace view does. OK, we can look at the code, and maybe we can kind of understand it. But let's dig in a little deeper. So this first section, right, what was happening? So we've got UMS generate URL calls a thing called shared cache fetch. And shared cache fetch calls off to a thing called shared cache, blah, 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 .aws. And then that takes 2 milliseconds. And then there's another call to UMS proxy that took 37 milliseconds. So let me dive into this a bit more. So what's actually being called? So OC Registry is calling UMS generate URL. That's calling shared cache fetch. And that makes 2 calls. OK, well, we've understood that from X-Ray. Fine. That's what's happening. So let's dive into this first one. So shared cache fetch. We can click onto it and see actually what's going on. So we can see from that very first screenshot that it took 2 milliseconds. And it was a remote call. That's what X-Ray has told us. We've then got some metadata about it. We've got these annotations. We can see that from the name shared cache, it's a get. With the annotations, we're getting a cache key. This is the key that we're getting. And the operation is a get. So we're fetching something from the cache. We can see even more data about it here. We've got, for example, start time, end time. It's not in progress anymore, stuff like that. We're really getting deep insight here now. So the second call is a remote call to retrieve a requested value. So similarly, it was like the other one was a remote call to a shared cache fetch. This is now UMS. We're calling off to UMX proxy. It's a HTTP endpoint that we're calling. We've got the request URL here. We can see that we're requesting a particular thing from a service. And we get the response status was a 200. And it took roughly 37 milliseconds to respond. So what's actually happening here? Like, what knowledge am I gaining from looking at this? So actually, we're getting a cache miss. So we're hitting the cache. It's returning without my key. And then I'm calling off to the underlying service to get it for real. But we seem to be getting an awful lot of cache misses. So going back to our original trace, we can see that we do shared cache fetch, and that takes 2 milliseconds. And then we call off to the underlying service, and that takes 37 milliseconds. Can anyone spot a problem here? Shout out. I seen you nodding. I heard somewhere, yeah, cache not being updated. Yeah, exactly. Cache not we're not populating. We're trying to get from the cache. There's nothing there, so we're going off to a service. But then we're not putting it back in the cache when we've got it. So yeah, great. We've spotted a bug. Like using X-Ray, we didn't have to trawl through logs. So yeah, that's exactly right. We're doing a cache get, but no cache set. So we can see here cache get, and we've got the annotations there. Yeah. So what do? We fix the bug, deploy, check X-Ray again. So this is the bug submitted. Fixed. So again, the same call, shared cache, the get. It took 2 milliseconds. And then we go off to the underlying service, 37 milliseconds. And then we've got the third call here, shared cache. which is, it took 9 milliseconds. We're actually calling that asynchronously. We see the bar going off the edges. It's taken 9 seconds, but we don't need to wait for that to complete in order to return. That's why the bar's going off the end of the... So we can return the value back to the user, but then asynchronously populate our cache. Oh. So yeah, that's what we're doing. And then if we dive into that final piece, we can see, yeah, the operation that we're doing now is a set. We're setting that cache key back. So then we see subsequent calls to this function. They're actually now we're getting cache hits, which is obviously what we wanted, and that's why we want to speed up our service. And we're talking like a 10 times speed up here. This was the bug being solved. So previously it was taking 41 milliseconds for this endpoint to return constantly. Now when we get a cache hit, we're getting returns of 4 milliseconds. So obviously we've sped up the service a lot. So that's just one example and why X-Ray gives us deep insight into our services when things go wrong. Analysis of the traces allows us to really understand information about how services are interacting with each other. And it's just another tool in your armory, right? You might have a bunch of different alerts and graphs and logs and all this sort of stuff, but X-Ray is just another one that is like, okay, when something goes wrong, and things do go wrong very, very often, you've just got this other tool to pick up and really start investigating into your services. So that was it. That's how we use it at Skyscanner. I think I'll hand back to Randall.
Thanks. Okay, so you guys, can you hear me? You guys can see how you could use X-Ray to really dive deep in various production telemetry. Was that running in production? Okay, so it was. I mean, it's a pretty powerful service that allows you to do that. And how many people have used something like Kibana or New Relic to kind of trace all of this stuff before? So this service is not a complete replacement for any of those, because you guys still use Kibana as well, and then you have the deep linking into X-Ray. So what it's allowing you to do is something that these other services don't allow you to do, which is dive deep on production telemetry as it's happening. So progress, and I want to cover a few different things, and I also want to check the time to see if we have enough time for a demo, and I think we do. So pricing is very, very cheap, or it's pay on demand. It's essentially the first 100,000 traces recorded per month are free, and then the first 1 million traces that you retrieve or scan or query are free, and then beyond that, it's $5 per million traces per month, and it's 50 cents per million for traces that you're scanning and querying. And you can define your sampling rules on Lambda and ELB and all of these other different services that you use to only sample errors or only sample 10% of your total request volume to kind of get a better idea of what's happening there. And also, you don't have to trace every single request. You can. So these are our currently supported frameworks and SDKs. We've got Java, and you can instrument Tomcat, Spring Boot, a bunch of servlet filters. You can do C# with .NET and .NET Core on Lambda. And Node.js, we have express filters and request filters and things like that. These are the services that are currently natively supported that will automatically generate trace IDs for you. ELB, Lambda, API Gateway, EC2, and Elastic Beanstalk. Elastic Beanstalk is just a combination of the above services. So you can also generate, and this is something that I don't have slides for, but I wanted to talk about it briefly. The coolest thing that I've seen so far is you're actually able to treat external services as nodes in your service graph. So even though you don't have the ability to instrument the code that's executing in those other sections, you are able to treat your calls out to that and measure the latency to these external services over time. And you can dive deep. You can say, okay, what's the P99? What's the 99th percentile value when I call out to this external service? And if it's 180 milliseconds when you really need it to be 10 milliseconds, you can kind of figure out, okay, what is different about this call that I'm making to this service that's causing it to take so much longer? And sometimes the answer is external service was just slower for some mystery. But often it could be I'm sending Unicode, or I'm sending doubly encoded stuff. All right, Do you guys want to see a demo? That was not energetic. For the purposes of any video recording, the audience was super enthused about a demo. I probably should have connected to the Ethernet cord up here. So Lambda functions are very, very simple to enable X-Ray on. It's basically you go into, you can say AWS Lambda configure or update function configuration, and then just enable tracing mode active. It's really straightforward, really simple to do that in Lambda. I can show you in the console as well. But you guys remember that selfie we took earlier, right? This is not the right region. Everybody remembers the selfie we took earlier, right? I have to have audio responses just because the videos can't see the incredibly enthusiastic nods from everybody in this room. So I've tried to replace as much of my life as possible with the Lambda function. So I have this one Lambda function that my mom still has not figured out that responds with my current location and health and well-being. But that's not the one we're looking for right now. We're looking for this one. This is the Selfie Processor. And being a millennial and self-obsessed, I take a lot of selfies. And then I like to analyze them using recognition. Has anybody seen recognition, the framework? So recognition, for those of you who are not aware, is kind of an image analysis framework that we have at AWS. And the IAM role that I have on this is delete Lambda XRay. Great. The way you can enable X-ray is to just click Enable Active Tracing. Now, one component of this to keep in mind is when you enable active tracing on a request, everything that comes through with a tracing, with trace as true in the request is going to be traced. But if you explicitly set that you don't want the request traced, it will not log that. In addition to that, this does take some memory. Running the daemon takes, at maximum, 5% of the total memory of your function. So it does have some minor performance hit. And it's important to keep that in mind with Lambda. It's not so important with EC2 or other services because the effect is negligible. But with Lambda, you're concerned about individual hundreds of milliseconds for execution because that's our smallest billing. So you want to try and make sure that you're executing quickly. OK, so we're going to SSH into an instance. It's not the right one. Hopefully this is the right one. We're going to figure out what the right instance is. Did anybody see my 1.5 factors of authentication earlier? That's the basis of my rejected PyCon talk. I can't remember which of these instances it's on. Let's go with this one. Oh. So I'll go into my selfies folder. And I'm just going to say, hey, copy all of these into this selfies bucket. Oh, unknown option recursive. Did I spell it wrong? I live stream and live code on Twitch, and the #1 problem that I have is spelling. OK, so that's going to run for a bit. And I'm doing it over SSH so that I don't destroy the Wi-Fi. You're welcome. And then we can go into X-Ray. And we should be able to see some results pretty darn fast. So I'm going to go with the last, I don't know, hour. And OK, so you can see there's this Twitter bot that we used earlier So those of you who are on Twitter, you can go follow @JRHunt, and you can see an example of the services that we were calling out to. That was the selfie we took earlier. I tweeted it out. It replaced all of our pictures with little cloud ninjas so that your faces are hidden. And you can see I called out to recognition. You can see I've got this response distribution graph here. I can zoom in on that, and I can see, OK, how often when I call out to this is it having some error? I'm putting some stuff in a tweets table. I am grabbing some stuff from S3. And I'm doing this Lambda function. And I can actually view the individual traces, and I can see what exactly is happening. And this is a Python function, and it's being instrumented pretty well. I'm not getting a ton of extra stuff. One of the advantages of X-Ray with Lambda is that you can see each of the individual attempts that it makes, because Lambda has automatic retry policies for events that fail. And you can see how long it was, what the dwell time of the function was. So if your Lambda function is being throttled, you can figure out how long was it waiting to execute. That's a lot of stuff that's just given to you for free from the Lambda service. And now we should be able to see this kind of selfies processor thing running. And OK, and you can immediately see I'm being throttled here by recognition. And I'm starting to get some errors in the Lambda function, and I can see the distribution of requests. And the algorithm that we use to build this map is really interesting. If you guys want, you can read all about it. It's called the T-digest algorithm. Fun stuff. So what I want to do is I actually want to find all of these requests that are being throttled, and I want to try and understand them. So I can dive deep very quickly. You can see I've got this query here that's just throttled as true. And I can see all these traces. I can see what's happening. And OK, well, I see that attempt number 1 failed, and I got an error. What was that error? It's not available yet, but it will be shortly. It's essentially going to say, you're being throttled by recognition. Yeah. So I'm being throttled by recognition. My provision throughput is exceeded. But then I see on attempt number 2, I succeeded, and it took 619 milliseconds. All in all, it's a pretty powerful service, X-Ray. And because I've zoomed in, there we go. You can see that things are still in progress here. And that's my only demo. We could do just a little bit of Q&A, but I'm also going to let you guys go out to your break earlier. I wanted to thank everybody very much for coming to this presentation. And I will remind you that you should absolutely follow me on Twitter, because I'm trying to beat Abby Fuller for followers. Thanks. And I also wanted to thank Skyscanner for coming out and talking. So Ashley, thanks a lot.